Hello, everybody. So I'm here for the second of the live introductory sections, a completely optional thing. And it's about 10 after, so I'm going to go ahead and assume that everybody's busy right now. I'm not going to be able to make it. It's an optional thing, so no problem there. But on the list of things I had ready, in case anybody was able to make it this evening, we are in an asynchronous online class. So it is sort of all on our own, right? All on our own time, our own schedules. When that works out, this is just a little feature in case anybody would find it useful. But it's about 10 after, so I'm going to go ahead and assume that nobody's going to be able to make it tonight. I had a list of things to go over, and in particular, there's one that I really wanted to at least make a short video. That was my plan, that if nobody showed up, I was going to add this one thing in a short video, because it's something I always like to express repeatedly in the classroom, and I feel it's missing from the online courses on programming. And that is our resources. We have some great resources, right? All sorts of textbooks, the one assigned for the class, and then tons and tons and tons of other programming textbooks. The internet is full of tutorials on programming. But the thing is, those are finished versions. Those are polished off. Those are already the final version. And the order that the computer needs those instructions in is not the order we think about them in. It's the first part of it. And then the second part is those are the polished off finished versions that we see in those nice tutorials and textbooks and things. So they always omit the error messages. And in the classroom, I like to throw error messages constantly to address, to go over how to make sense of the error message and how to fix it when we see that error message. So as we go into this, that's the point I wanted to express most is as you go through this, programming is not that final polished version. Even in the tutorials where it looks like they're doing it in live time, those are scripted and prepared and usually practiced for. I do that. I practice all my lectures for software development before giving the lecture. I practice them ahead of time, but I still include errors to see those error messages and learn how to deal with them. Because you all have probably noticed by now that when we write code, we don't immediately end up with that final version that's ready to run. We do something and then fix the error messages, and then it works. Or then we can start the actual debugging process on our algorithms. So I wanted to talk about those 2 points. I guess I'll just kind of go through an example here. I'll share the screen, and if somebody does decide to pop in here, I'll stop this recording and we'll just use the live one, talking to people with it. But this will be short, just a quick pass at this. So I'll share my screen, and I need somewhere to type Python. I'll use idle. That's a good one. I have a number of ways available. There's different ones. The statewide shell said to use Visual Studio Code, which I almost never use myself. Especially on the very first run of the course shell, the new statewide course shell, I didn't want to make any changes so we can find the typos. But there are lots of IDEs available, and usually in the 200 level programming class, that's where I recommend using a different one every week to find the one you like, the one that you think that makes the most sense to you and works best for you. But I'll just use the basic idle, the standard one that comes with Python for this example. Create a new file. So what's a simple example? Maybe a payroll calculator. That's a good one, right? We have some employee's name, employee, and we're going to get that from the user. What is the employee's name? So input, we'll ask for an input. Please enter the name, the employee's name. Normal prompt, nothing too fancy there. To calculate their pay, we need the rate of pay and their hour, how many hours they worked. So really, we could hard code the other stuff. I'll abbreviate this even more. We've seen inputs, and there's nothing in the point I wanted to express there. So I'll just hard code one in. So employee is named Bob. Bob does not represent anybody. I just made that name up as it's just a common name. I often use it as examples. Maybe Bob makes $22.34 an hour. Not great pay, not terrible pay, somewhere in the middle, I guess. And the one we do need input from is how many hours did he work? So we'll say hours, and that's coming from the user. So we'll ask, how many hours did plus whatever the employee's name is. Whoops. The plus sign goes here. Work this week. Actually, I started to make a typo, and I think I'm going to go back to that typo because one of the things I just said was talking about the error messages. So let's throw an error message here. You can input, and then we can do the calculation. It's always a good rule of thumb to run a test every chance you get. You don't want to wait to the very end to run a test. So if I go ahead and save this. Oh, which while I'm at it, here in idle, if you ever need to know where your Python is installed at, if you open a new editor, text editor here in idle, when you go to save for the first time, by default, it will try to save where Python is installed. So if you just grab the address from there, that's the quickest way to find where Python is installed on your machine. It's probably not where you want to save your Python scripts. So go over to wherever your working folder is, and I'll call this payroll.py. And well, I'm not finished, but we've gone far enough. We can run a test. So F5. Oh, get this invalid syntax and get a nice little suggestion. So that error message is pretty easy to work with, except that it's wrong in this case. I'll pause for a second. I manually typed in the error. I was in a classroom. I would ask people, do you see what's wrong at this point? And I manually typed it in. So perhaps you forgot a comma. No, did not forget a comma because just did regular concatenation. I pretty much never use the comma thing in Python. That only works for the standard output in Python. That only works back to the console that we're running the script in. And usually we're not running a script in the console. We're running, our script opens up a GUI and our words need to go there. So that comma thing in the prints and inputs doesn't necessarily work on a GUI. So I usually go with normal string concatenation. So the error message there, you can see it gives a suggestion, but maybe not exactly the right suggestion. So fix that error, save it, Control S, the normal save, F5 to run again. Okay, we get the numbers. How many hours did Bob work this week? Bob worked 5 hours this week. Okay, got to the end, no more error messages. So that's something. There's a slight problem here though. I'll go ahead and calculate gross pay. I'm gonna ignore the overtime for now. I believe everybody has seen some Python before. And from the introduction discussion boards, even those who haven't seen Python necessarily before have seen programming before. So you all know how to do an if else and work in the overtime thing. So I'm just gonna ignore overtime and do the simple gross is hours times rate. And then we'll print the employee's name plus made a $sign plus whatever the gross is plus this pay period. I guess that's a good sentence for output. There's a problem here. I'll pause for a second. Do you all see the problem as you're watching the video? If you don't see it, pause it and see if you recognize the problem before I fix it. Or before we look at the error message, because that's what I wanted to look at. Because that's missing. how many hours did he work? Let's say Bob worked 10 hours. That'll be an easy one to check the math on. Should be 2234 times 10 should be 223.40. Oh, there we go. Something went wrong. So we need to see what went wrong. And by default, we're going to get a trace back. If you're in an IPython console, such as in Jupyter Notebooks, you get a little bit more information. Your traceback also points to the line where it crashed. It says it crashed on line 8. But there's a slight problem here. That doesn't necessarily mean our problem is on line 8. The only thing we can say for certain is the problem did not occur after line 8. Right? If we're in a much bigger program, several thousand lines, and it crashes on line 800, it could have crashed. It could have actually arisen from a problem anywhere in those first 799 lines. All we know for certain is that it did not happen after where the error messages points us at. So type error, that means we used the wrong data type. Python's open typed, but open typed is not the same as loosely typed. Some of y'all may have worked with loosely typed languages before. We can always spot those because the variables start with a $sign. PHP is a very common one you may have seen. PowerShell, we do that. There's a whole bunch of them, but when usually we can spot loosely typed languages because all the variables start with a $sign, and in those we only have one data type, so we don't have to worry about whether we have an integer or a string. And Python's halfway there; it's open typed. When we create a variable, we don't have to worry about that. But once we put something in there, then it's set. So employee is taken in a string. So after that, we have to, once the computer uses up all the resources to figure out that that's a string, we kind of have to stick with that being a string. Same thing with rate, that's a floating point number. Hours, it's our standard input, and the standard input's the keyboard. The keyboards are ASCII or Unicode characters, which means that's a string. So that's a string. Once the Python interpreter figures out that's a string, we have to stick with that. So that's what a type error is. So the interpreter thinks we had some type of data that can't be used for multiplication. We can't multiply a non-int with a float. Oh, we can't multiply a sequence by a float. A sequence of characters cannot be multiplied with a floating point number, is what that's saying. So as this semester progresses, that's the point I wanted to make, is pay close attention to the error messages. Don't try to jump in and fix them as quick as you can to move on, because things in the classroom, we're under tight time constraints. Most modern problems in programming would not fit in a classroom at all. So we have to cover the basics. So everything that you see in a classroom is specifically designed to fit in our time constraints. So when you get to the big modern problems that are really hard to figure out, you're gonna want to know how to figure out the error messages. And textbooks and well-prepared tutorials always skip right over those. We don't ever see them. And then when we see them constantly, it makes people think they're doing something wrong because they didn't see those in the example. And they just immediately try to fix stuff as quick as they can. And sometimes that can lead to other problems if you're not careful with how you fix it. So the problem here is hours is a string because it's coming from the keyboard, and it's we're trying to do math with it. So I'm going to retype this line. Well, if I was going to type it all together and going to do that, I'm going to just put Control X to put it on the clipboard. Because another thing that I found useful is a lot of people are so used to working left to right, top to bottom, the way we do English. But we're not in English. We're in the Python language, not the English language. The computer needs this to be in a certain order, going left to right, top to bottom. But even though we write it left to right, top to bottom, the example I always like to use is x equals x plus 1. It's a very common line in programming. You've surely seen something like that before, right? But the very fact that that line works shows us for certain that the computer, the Python interpreter, reads these instructions from right to left, not from left to right. Because otherwise we would have an infinite recursive call when we tried to do that if we read that instruction left to right. So the fact that that works tells us immediately that the order we write it in is not the order the interpreter runs it in. And I found it's very useful. Another thing missing in those textbooks and tutorials when we see the final example, I found it's much more useful to bounce around, move back and forth, and put the code together in the order I think about it in. And it just needs to be in that left to right, top to bottom order for the Python interpreter at the end. We have arrows on the keyboard, right? We can move this cursor up and down, back and forth, anywhere we want it. So we do not have to write our code in the same order the interpreter needs it in. And on things like this, the way my mind thinks about it, I think about the input first. So lines like this, I tend to work from the inside outward because I think about the input first. So really what I think about first is the prompt. Think about the prompt, and then that goes into the input, and then wrap that in a casting. So that's probably a floating point number, because if you work 35.5 hours and your employee only paid you for 35 hours, you would probably be very upset about that, right? So we need that little partial hours, because we get paid for those as well. And it's sort of working from the inside out in the order that my mind thinks about it in. That can be far more productive. And those are the 2 points that always seem to me to be missing when we see only those polished final versions in textbooks and tutorials. The process of putting it together. We're not in English. We do not, English goes left to right, top to bottom. Python does not go that order, and the interpreter does not do it in the same order we write it in. So the best thing to do is to move your cursor around, use those arrow keys or the mouse and click in different spots and jump around and put it together in the order you think about it in, and just make sure it's in the correct order for the end. So now that's a number. One more error message, which you've seen, surely everybody has seen many times by this point. Okay, so Bob worked 35 hours. Oh, another traceback, something went wrong. And traceback means that the program crashed. It hit an instruction it could not run. So the computer goes back a few steps. It's usually relative to how many is run. Right? If you're 10,000 lines into a program, it's not going to go back 10,000 lines. So it goes back a few steps relative to how many have already run, and runs the last few lines to see where it crashes. So it went back and then paid attention to very careful attention to every line that ran, and said it stopped on line 12. So somewhere before line 12 or before or including line 12, there was an error. Type error. So again, we have the wrong type of data. Can only concatenate string. We can only put concatenate strings. We can't concatenate floating point numbers. So a casting issue, y'all have probably seen that before. This needs to be cast into a string, just like this was cast into a floating point number. Which usually when I'm putting that together, I do the same thing I just mentioned on the input. I'll put the line together like this, and then come back and do a pass that makes it all like one. And I recently learned that a lot of people don't know about this on text editors, but most of your text editor, if you highlight an entire word and then hit your open parentheses, it will wrap it in there. Idle's a really lousy text editor, so it doesn't do that. But a lot of times you don't have to type the first text editor and then hit over and do the closing one, unless you're in a lousy text editor. I'll hit Control Z a couple times to undo that. In most of the nice text editors, VS Code is definitely one of these. you can highlight the word and just hit the opening parenthesis, and it'll put the closing parenthesis on there as well. Same thing with curly braces and several other symbols, but we don't use those in Python, mostly parentheses. So I'm in the lousy text editor, so I have to actually move the cursor around and type those in there. And again, it's kind of working from the inside out instead of left to right, straight across. The order my mind thinks about it in. I think about what parts need to be there and then put them in. Well, I might as well run that without the error messages because there's a better way to do this though. So save that, run that. Should get all the way to the end now, though I was talking and typing the whole time. So, okay, looks like it ran without error messages. But on that last part, there's a better way to do that. Those who saw Python in the 120 and 140 class, you would have seen a lot of that because it generalizes to our other languages better. But an even better option is to not concatenate at all. To an alternative we have, if we take out these plus signs, take out these quotation marks, instead of using several different pieces, it'd be nice if we could just put our things right there. And I use the end key. If you're not used to those, the home and end keys are very, very much your friends when programming. They're always in different spots on keyboards, but you definitely want to learn where home and end are. I have an indented line. The end key will put your cursor to the end of the line and the home key to the beginning of the line. And before the days of a mouse, most of y'all are probably too young to remember that. When we needed to highlight, we'd hold down Shift and move that cursor around. And it often happens in programming that we need to highlight an entire line. So a good way to do that is click anywhere on the line, push the end key, and then hold Shift and Home, and that'll highlight the whole line a lot quicker than using the arrows or trying to drag your mouse around. So you might want to get used to using the home and end keys. Thought I'd mention that since I just threw it in there. So now back to where we were. Oh, and if it's indented, the home key will toggle between the indent levels. So it'll go to the beginning of where the typing starts. And then the next time you hit home, it'll go over all the way over to the edge, to the start of the line before the indent. Very useful keys. Sorry, so back to the side step, back to where we were before the side step, it'd be nice to just type these variables right in here. Oops, just going with the dollar sign. And to do that, an easier way to do that in Python that doesn't seem to show up in the SDEV 120 or 140 class is we can print a formatted string. So you just put an F in front of the string. Another useful one, because it's not mentioned in our textbook, is you can put a B there, and that turns that into Unicode. Python is a programming language. Everything about it was made to be easier for the human. There's some trade-offs there. One of those, there's a standard for strings, which is Unicode, but Python doesn't work with that Unicode standard. So Python strings are not compatible with the strings we use everywhere else in computers. If we put a B out front, that's going to turn this into a binary string, which is Unicode. So then we can work with other software. That'll be a useful one that's not mentioned in our textbook, so I thought I'd show it. But what we need here is a formatted string. So if we put an F in front, then on our variables, we can put our variables inside of curly braces. And there's some other options there too. So it's formatting. So we have how many decimal places it shows and stuff. And y'all, if you like this style, that's an easy one to find. I believe W3 Schools has examples using this. But that gives us the ability to put our variables right in the string without having to worry about the concatenation and possible type errors if we forget casting. Because it's casting, changing the data type is automated in a formatted string. Pretty much all our languages have formatted strings. So even people who've worked with other languages before have probably seen formatted strings. So if I save that and run that, we should see the same thing. 22 hours. You can see our result is exactly the same. I made so much money this week, but it bypassed that concatenation, which leads to an error. So that's the 2 points that I really wanted to express, because I always feel like those are missing when all we see is those final polished versions. The final version has to be in a certain order, but that does not mean we have to put it together in that order. And actually, it's more productive if we don't put it together in that order, because that order it needs to be in for the computer is not usually the order a human thinks about it in. So kind of bounce around, and it can be work out much better to put the code together in the order you think about it in, instead of the order the computer needs it in, and just make sure it's in the right order at the end. And as you get used to polished examples and textbooks and tutorials, it's going to make you feel like error messages are a big issue, but don't be scared of an error message. Don't immediately jump and try to get rid of it as quick as you can. Get familiar with them, learn to read them, make sense of what they're saying, what line it is. Read through every line and make sure it makes sense what went wrong, because in the long run, when you get to really big modern software problems, knowing how to interpret the error message will be far more productive than desperate attempts to avoid error messages altogether. So I always like to throw error messages in class examples, because that's definitely missing seeing the polished versions. And when all we see is the final result version of the code, we're missing the process by which it goes together. So looks like nobody was able to make it this evening, so I thought I'd make a short video expressing those 2 points. These were the only 2 live live sessions that were immediately scheduled. I'm available to help if you need me. I'm always happy to help. My contact information is in the syllabus. If some people would like to have live sessions, let me know, and I can put together a survey or something to find out what the best times for people are, and try to schedule some sessions at those times so we can go over those things that, well, really, so that you can meet with me at some point, and it's not that, hopefully won't feel like you're completely on your own working through the online course. But I'm always happy to help. If you have any questions, let me know. Please keep those 2 things in mind. You don't have to work. It doesn't have to be the final order right off the bat. Put it together in the order your mind thinks about it in, and pay close attention to the error messages. Learn to make sense of those, because in the long run, after you finish everything that was designed for a classroom, seeing those error messages is going to be harder to fix in the big modern problems. So you want to make sure you can understand what the error messages are telling you. If anybody has any questions, let me know. We'll see you all soon.